Enter Tom Schuler, who through Solidia Technologies is creating a new form of cement, which is the main component of concrete, that is massively innovative and massively important for the environment in that it actually captures CO2 rather than emitting it. So please join me in welcoming Tom to the program. Tom, thanks so much for being here.
Hey, Lindsay, thanks for having me. And I have to admit, when Nick initially said, he goes, look, here's what we're going to do. I want you to participate in this panel called Existential Threats. And I sat back and I thought about it in a second. I was like, I said, Nick, okay, existential threats, concrete, and you want me to go last and close the session. I said, you do know we're concrete from New Jersey. Most people don't consider that a very sexy way to close, but let me see if I can tell you a little bit more about this industry. You know, existential threats to me were always kind of those things that they made movies out of, you know? I mean, it was a big wave or a storm, or there was a big lizard, or, you know, whatever it is. But I never really thought about it in terms of maybe what we've learned about in the last year is those things that maybe you don't see that become existential threats, but maybe the worst. And a lot of what we talked about here tonight are the things that are right in front of you. I mean, they're right in front of you all the time and you don't even see them and you have no idea what kind of impact they can have. Well, let me introduce you to concrete. You know, concrete's the second most used material on the planet after water. And A, most of you didn't know that. And B, most of you didn't really care. Just that thing that's always been around that you could always count on, you just kind of ignore it. And maybe what's even more important is the cement that is made that holds that concrete together. That production process emits about a ton of CO2 for every ton of concrete. That makes it responsible for almost 8% of all of the CO2 that's emitted every year. And that also makes them about the second largest emitter of industrial CO2 on the planet. Now look, this industry knows it's got a problem. They are working diligently and have been for a long, long time trying to figure out how to solve this thing. But they can't do it by themselves. You know, this is a conservative industry. They've got long-standing traditions. And they need startup companies like ours because one of the things that we can help these big conservative companies do is de-risk new technologies so that they can take these big leaps forward to solve some of the problems they've got in front of them. Now, you know, Lindsay mentioned earlier, so this is a market that's thousands of years old. I mean, the Pantheon in Rome is 2,000 years old and it's still standing and it's made out of concrete. Okay, it's reinforced with horsehair and some other stuff. So it's a little bit different, but it's still there. I mean, this industry is so old that it lost the recipe for 900 years. I mean, that's how old this thing is. How do you even do that? Well, fortunately, it was rediscovered in the 1700s. It was reinvented in the 1800s, and it's basically the same as it was then. So over the last 200 years, they really haven't innovated that much. Now, there's been innovation. It's just not enough to solve the problem that they've got today. So part of our job is to help them figure that out. Now, for you guys to understand this, you've got to understand the difference between cement and concrete because our technology actually addresses both cement and concrete. So if you don't learn anything tonight, one of the things you are going to learn is the difference between cement and concrete because they're not the same. All right, so here it is. Cement is the glue that holds concrete together. They are very different. So the cement truck that you see running down the street, not a cement truck, it's a concrete truck. It's got a little bit of cement in it, but it's a concrete truck. Cement sidewalk, it's a concrete sidewalk. So people have been messing with you for a long time. It's okay, most of you didn't know that to begin with. So that's important because we address both of those. And so let me describe to you how that works. So let's start with cement. Right? Cement is one of the most ubiquitous raw materials around the world. And it's going to be with us for a long time. And it's that way because the raw materials are everywhere. So as we're looking at the markets today, you know, it's not going anywhere. You know, with urbanization and population growth, we're going to be using more concrete, not less of it. And so the production of cement is going to be just as important. So here's how you make it. You take limestone, which you find everywhere, and that's got calcium in it. And you take a source of silica, like sand, and you mix those two together. That's about 2/3 calcium, about a third silica, and you mix them together in what's called a cement kiln. Now, these kilns, if you've never seen one, are fascinating. They're huge. They're about 100 meters long, probably 10 meters high, and they rotate. And they're about 1,500 degrees Celsius. So if you look down this thing, it really does look like the gates of hell. So cut back to the movie referenced earlier. Now, once it comes out of that process, every ton of cement that I make produces almost a ton of CO2. That's the problem. So when the cement comes out, it gets ground up, and then it gets shipped to customers to be turned into concrete. So that's how you make cement. Now, for about 50 years, people have been trying to figure out how to carbonate that cement, not as a sustainability play, but as a way to make the concrete more durable. The problem was the cement that gets made likes to react with water, but it also likes to react with CO2. And if those two things are happening at the same time, you really don't end up with a very good product. So what we do to that cement kiln is we don't do a whole lot of anything. We use exactly the same kiln. We use exactly the same raw materials. We just use a little bit different recipes. So instead of about 2/3 calcium carbonate and a third sand, we use about 50-50. And that subtle change in the recipe fundamentally changes the process, because now the chemistry happens at about 1,200 degrees C. Still looks like the gates of hell, but a much lower temperature. And that causes a couple of things to happen. Because I'm using less limestone and lower energy, I'm producing less CO2. So instead of about a ton for every ton of cement produced, we produce almost 30% less. We also use about 30% less energy. This is a very energy intensive industry, and we use much less energy. We actually end up producing more material with the same amount of raw materials because we're not sending as much stuff up the stack. Now, when this cement comes out of the other end, it looks pretty much like Portland cement, as it's called, except for one important difference. Portland cement reacts with water. We don't react with water, like never. It won't react with water. It will only react with CO2. And so that's where the next step begins is, okay, well, I've got the cement. It produces less CO2. It uses less energy. It produces more product with the same materials. It should be less expensive. I need to figure out a way to fill my kiln. So I got to figure out how to sell this stuff. So I got to go to the concrete market. So now let's switch over to concrete, not cement, concrete. So the concrete market is really split into two pieces, right? You've got the precast market, which is a market where everything is made in an industrial controlled setting. That's actually the growing part of the market right now as countries industrialize. The other part's the ready mix market. That's where you put it in a truck, it runs down the road, you dump it somewhere. You've only got 35 minutes to get it into the truck and down the road. So if you ever see a concrete truck behind you, word to the wise, get out of the way. So we're going to talk about just the precast market because that's where we're focused right now, and it's the easiest to understand. So to make concrete, you take aggregate or little rocks, you mix it with sand, with water, and with cement. You put it in a big mixer, the slop comes out, and you put it into a mold that then forms whatever you want to form, whether it's a pipe or a block or whatever it is you want to use. And then typically that is then put into some kind of a chamber, whether to expose it to steam so that it'll accelerate the cure. And then they put it into the inventory for 28 days. It actually takes concrete 28 days to come to its full strength. Now they may ship it before then, but you're not going to get full, strength concrete for a while. Now we do exactly the same thing. We use the same aggregate, the same cement. We use water. We need water in our process. And then we change the cement. We use the same mixer. We use the same press. But then instead of going into a steam chamber, we go into a chamber that's filled with CO2. Now, this isn't just any CO2. This is CO2 that comes from waste gas. People always ask, well, where does the CO2 come from? Well, most of the CO2 that we use today is captured from some flue stack from a process, whether it's making ethylene, whether it's making ammonia. It's captured, it's cleaned, compressed, and shipped, and then we use it to cure our concrete. Now, the concrete that comes out of the other end after 24 hours is at full strength. We don't wait 28 days, we wait 24 hours, and it's ready to go. That's a huge impact on the industry, and all of the things that the industry thought for those 50 years. It would be more durable, it would have better performance. is what happens with this concrete. So you have to remember the concrete guys in their minds, they don't have a CO2 problem, right? That's the cement guys' problem. So we have to go to them and talk to them about how this is going to be better business. They're going to make more money. They're going to have a better product. And that's what we do today. Now, the ready mix market, as you can imagine, is a little bit different. I can't figure out a way so far to be able to back up a truckload full of CO2 on a roadbed and somehow safely cure this thing in a way that's cost effective for anybody. So we had to think of something a little bit different. And for us, what we came up with was a family of chemicals that you can make from CO2. It had to be in a liquid or solid form, but then we could mix it with our cement and it would cure. So we found this family of chemicals called carboxylates, which I still can't spell, but it means things like citric acid, which is what you find in orange juice, or tartaric acid, the stuff at the bottom of the wine bottle, which is what I'm going to have after we're done here. Those things actually react really, really quickly with our cement. In fact, right now, a little bit too quickly. But what they do is, because they're formed with CO2, something like citric acid, which is essentially made out of 4 CO2 atoms, when that carbon reacts with our calcium, now I've almost quadrupled the amount of carbon that I'm storing. I effectively have made that concrete carbon negative. Now, we're a few years away from being able to do that, but as you can imagine, this has a tremendous impact on the marketplace. So let me give you a little bit of a concept of how big is this thing. And I think the biggest trouble that most people have is conceptualizing how large this market is. And the best way I know how to do that is translate it to what kind of impact it could have on a market compared to some other stuff that we're familiar with. If we get 1% market share of this gigantic market that Lindsay described earlier, that 1% translates to about 890 million trees that you just planted. Now, I'm not suggesting you don't go plant trees to help sustainability. You need to do that. But just to show you the kind of impact, it translates to about 3.5 million electric vehicles that you would put on the road. That's the kind of impact that this market can have. So as you can imagine, we're starting with this movie where you're pretty sure that the concrete and cement guys are the villain, and they're going to be the bad guy, and they're the one that gets swept away by the hurricane or whatever it is. But in this movie, we could take that villain and they could actually end up being the hero. And that's what's so fascinating about the market. It's fascinating about our partners, and I think it's fascinating thing about our company. So with that, Lindsay, I'll pass it back to you and see if we got any questions.
Tom, who knew that cement and concrete could be such a fascinating topic? Thank you.
Thank you.
We have a couple of great questions from the audience. The first one comes from Toby Bryce. He mentioned that there's a pending bill in the New York State legislature that incentivizes the public procurement of low carbon concrete. So curious on a policy perspective, what sort of policy measures would actually help to scale this technology for Solidia?
Yeah, that's a great question. And the New York bill is one that we're obviously very interested in. There's also a bill in New Jersey that's going through the works right now in order to encourage that kind of investment. First of all, buying green is really a significant way that will help companies like ours to be able to get through that. And we've got some fairly standard policies that we go through. Having a carbon scheme in place, we'll call it a scheme. That always sounds bad, but that's what they're called around the world, is really going to be an important part of, in German, they call it Zucker und Schwitzen, so sugars and switches, right? You've got to have some motivation for the industry to get rid of something bad, and then have an encouragement on the other end to use those products downstream. So a carbon scheme, buying green. But then I think the one thing that most people miss that we talk about, and we talk with governments about this all around the world, are things that actually enable the industry to transition, right? For us to be able to work, as an example, at a cement plant, the biggest expense they have for us is managing the supply chain. Do I have a silo that I can store this stuff in so that I don't mix my peanut butter with my chocolate, right? You don't want to do that with Portland cement and our cement at this point, because mixing them is not a good idea. Well, is there a way to help those companies manufacture that? Same thing with the concrete guys. How do we get them to transition to this new technology? So, we've got a couple of things that we work with pretty traditionally. There's definitely some things that will help. And we spend a lot of time talking to policymakers, trying to help them understand not just what companies like us could benefit from, but also the partners in the chain. And by the way, there's not enough CO2 in the world. I know, the one thing that people don't get right now is everybody talks about CO2, but I am so short of CO2 with what I need to do that it's become a real problem.
That is a shocking thing to hear out of anyone's mouth. So crazy how your technology works. All right, there's one other question that I want to share from our audience. This is from Philip Miller. He has a question about rebar and wonders why the industry or is the industry adopting more rebar into the sorts of technology that you're developing to expand the lifespan of the structures that are built?
Yeah, this is always the question that low carbon concretes get. So let me address that. The one thing that I will tell you, let's go back to the Pantheon that we talked about earlier. One of the reasons it didn't fall down is because there's no steel in it. One of the things that we did to shorten the lifespan of concrete more than anything was put steel in it. Now that was to make it, much more flexible, but it actually, in some cases causes more trouble than it solves. But let's talk about our concrete in particular. The whole idea was that with low carbon concretes, if I put steel in it, that because it's got a lower pH, right, it's actually going to be more aggressive. It's going to cause the steel to corrode faster. Well, I tell you what we've learned in the last 18 months is that's not what happens. It was kind of one of those urban myths that everybody said, well, that should be what happens, but nobody ever really looked. Well, we looked, and what we've actually found out is we think that our concrete's actually going to be more durable when it's reinforced. For some reason, the structure that we have actually takes the stuff that causes trouble and pulls it away from the steel to actually allow it to last longer. So it's one of those myths that we've been able to dispel by doing some great science. We get a bunch of young guys that are wicked smart, and they're asking questions in a very different way that the industry really hasn't thought about because, they've been relying on the same thing for a couple hundred years.
Thank you. Okay, one last question from Ravi Chandran. Is it possible to refurbish existing construction with your product?
Yeah, I think the refurbishment when you look at it depends on what you're trying to do. If you're trying to repair, then certainly the ready mix product that I talked about earlier will work fine up against Portland cement concrete, but I'd have to understand a little bit more about what you were thinking. But certainly as they begin replacing pieces with pieces, the physical properties are about the same. The loads are going to be the same. The sizes will be the same. We're probably actually a little bit stronger. So I think in terms of replacing parts with identical parts that look better and last longer, yeah, we can do that now.
Thank you. Tom, I really appreciate you spending this evening with us and educating us all on the sort of technology that you're building. It's been a pleasure to hear you speak and to teach us about what this can mean in terms of the impact on the environment. So thank you so much for joining us tonight.